So in today's lesson, we're going to be using what we learned yesterday about the sides of a right triangle to solve for either sides or angles. So as a quick review, yesterday, you guys learned that there's three sides of a right triangle: the opposite, the adjacent, and the hypotenuse. And if you'll remember, the hypotenuse is always the longest side. The adjacent means attached, and the opposite is all the way across and not touching the angle that we're looking with or the perspective that we're looking from. So in this scenario, if I said we were looking at this top angle up here, I would first identify my hypotenuse, which is across from the 90, so it would be my longest side here. Attached or adjacent is going to be the second side making up that angle, and opposite is going to be all the way over here and not touching the angle that we're looking from. And just again, a reminder, you're going to want to use your formula triangles. So sine of your angle is equal to the opposite over the hypotenuse. Cosine of your angle is the adjacent over hypotenuse. And tangent is opposite over adjacent. So tan of your angle is opposite over adjacent. And I'll try to get these in a formula sheet for you guys so you can see them a bit better here. Opposite over adjacent. So you're going to want those formula triangles while we go through the next two concepts, solving for sides and solving for angles, because these formula triangles tell us exactly what we're going to be doing, whether we're multiplying, dividing, or what it is that we're doing. Grab your calculator, make sure you're in degree mode. Again, that means you have to have a box with a D in it on the top, or DET. So first we're going to be calculating for sides, and I just took the top four from the worksheet that I posted on Edsby. And I'm going to focus right now on number one here at the top. So number one gives us a right triangle, and it's telling me to look from this angle perspective. It's a 35-degree angle. So when I label my OA and H, I can see that my hypotenuse is here, my adjacent would be on the bottom, and my opposite is over here. In today's lesson, I don't want you focusing on all three sides. I want you to focus on the side length that you have a measurement for, so in this case, hypotenuse, and the side you're looking for, which is the opposite. There's nothing on my adjacent side, so I'm actually going to get rid of that label so I can appropriately see what sides I'm working with. In this scenario, I have the opposite and the hypotenuse. If I go back to the formulas, opposite and hypotenuse is my sine function, opposite and hypotenuse. So I'm going to set up my formula here. Sine of my angle is equal to opposite over hypotenuse. Actually, let me go back to my formula triangle for a second. You guys probably remember from grade 9 science, or even some of your algebra in grade 9, that when you're working with a particular formula, what you're going to do is identify what you're solving for. In this case, I'm solving for the opposite. So I'm going to look at my remaining two pieces of information to figure out whether I'm multiplying or dividing. Side by side means multiplication. So I'm going to end up actually multiplying sine of my angle times hypotenuse. If you don't see that quite clearly, I'm just going to show you what the formula looks like set up. You'll see that it ends up being multiplication. So sine of my angle equals opposite over hypotenuse. So sine of 35 degrees equals my opposite, which in this case is B, I don't know it, over my hypotenuse, which is 16. B is my variable. It's currently being divided by 16. So to undo division, you have to do multiplication. So it's basic algebra here that we're going to be working with. So we're just going to multiply both sides by 16. What you do to one side of a formula, you have to do to the other. So multiply by 16 on the left-hand side. We'll cancel these. but I also have to multiply 16 over here on the, on the left-hand side, multiply it on the right and also on the left. Now I'm gonna grab my calculator. I'm gonna do 16 times sine of 35 and hit equals. You will absolutely need to do this on your calculator because you do not know what sine of 35 is as a ratio, but your calculator does. So 16 times sine 35. Sometimes you have to use brackets. Sometimes you have to close the bracket. So please grab your calculator and play around with this. 16 times sine 35 is giving me 19.177. So I'm just going to go ahead and round that to 9.177. So I'm going to round that to 9.2. And this triangle is given to me in centimeters. So I'm going to use appropriate units. So I will say 9.2 centimeters is side B. Now I did basic algebra here to solve and multiply by the 16. If you use the formula triangle, when you cover up the O, you'll realize you're multiplying sine of 35 times the hypotenuse, which is 16. So either use your formula triangle or basic algebra, both get you to the same end answer. So now I'm going to look at number 2 here. Take a look at number 2. Number 2 says that I'm looking at this angle down here. It's a 67-degree angle. So from this perspective, I know my hypotenuse is the longest side. My adjacent is the one that's attached, and my opposite will be all the way across. Again, however, you're going to focus on the one you're looking for or solving for, and the one you know a measurement about. The one that has nothing on it, I'm going to get rid of it. So I don't want A because there's nothing there. They don't ask me to solve for it. It is not part of my calculations. Now, if you look here, again, I have opposite and I have hypotenuse. So this is going to be another sine calculation. Let me go back to the formula triangle for a second. In this case, I'm actually solving for hypotenuse. So different from the one above where I solved for opposite. This one I'm solving for hypotenuse. My formula triangle is going to be very helpful here. My hypotenuse is on the bottom. So when you're solving for something that's on the bottom, the remaining two things tell you what you're doing with them. If they are above each other, it's going to be division. So my formula ends up rearranging to be hypotenuse will equal the opposite divided by sine theta. The hypotenuse is equal to the opposite divided by sine theta. So number 2, I just set up my formula here. My hypotenuse is going to equal the opposite divided by sine theta. So my opposite side length, the number 2, so we're down here now, is 8 meters long, and my angle is 67. So I'm going to have the hypotenuse equals 8 divided by sine of 67. Hypotenuse then becomes, so you can either use your fraction button or just straight do division. 8 divided by sine 67 gives me 8.69. I'm going to round that up to 8.7 meters in this scenario because of the units of the triangle given to me. And if we want to just kind of use logic here to make sure we're doing this correctly, my hypotenuse should be longer than opposite. It should be my longest side. So 8.7 is longer than 8. So that does appear to be correct. If you'd accidentally multiplied, you'd get a side shorter than 8. And please be a good problem solver and ask yourself if your answer makes sense. Due to my screenshot, I'm actually going to jump over to number 7. So you guys can take a look at the rest of them below, but for now we're going to look at number 7. Angle here is 60 degrees. Opposite, my hypotenuse is opposite the 90, so here. Adjacent is here, and my opposite is all the way across. Again, focus on what's given to you and what you're solving for. So I'm going to focus on the hypotenuse because it's given to me, and the opposite here. But my hypotenuse, my adjacent, I don't have. So O and H again. So this is another sine question. They're not all going to be sine. Please use the appropriate means of identifying your side lengths. It's going to be sine, and I'm solving for opposite. So I'm just going to grab my triangle here. And if you're looking for opposite, I should have done that. Sorry for 1 second. If you're looking for the opposite, which is in the top, you will end up multiplying the sine theta and the hypotenuse. So sine theta is here, opposite's here, hypotenuse. Since I'm solving for my O, I'm going to multiply sine theta times h. So let me just rearrange this one. My opposite side length, which in this case is j, is going to equal sine theta, so sine of 60, times my hypotenuse, which is 8. If you want to set up the whole formula, go ahead, or just grab your formula triangle. Either way, play around with it, see which one's easier. When I do that, I get 6.928, something around to 6.9 kilometers in this case. Okay, we'll do one more here. Hopefully this one is not a sine question. Hopefully it's the other ratios. Number 8, my angle's here. My hypotenuse is across from the 90. Adjacent is attached to my angle. Opposites all the way across. In this scenario, I'm looking for my adjacent and I have the hypotenuse, so great. This one is not sine. I'm going to erase the O so we don't focus on it. A and H is actually cosine. So if I look back here, I'm going to grab this formula triangle and I'm solving for A, that's where my variable is, or adjacent. So if I use my formula triangle, if I'm solving for A, these two get multiplied. Cosine theta will be multiplied to 8. So my adjacent side length, which in this case is variable K, there we go, number 8, variable K, sorry, I have a bit of a screen issue here, is going to be sine theta, so sine of 79 times 15. Again, you have got to use a calculator. Sine 79, we have no idea what that is. It's a decimal, so I'm just going to plug that into the calculator. Oh, I just did sine. I hope you guys caught me. This is cosine. So used to using sine, cosine, because it's adjacent and hypotenuse. We'll get a wrong, incorrect answer if we use the wrong trig ratio. Cosine 79 times 15, 2.862. So let's say 2.9 millimeters. So there's several more questions on this worksheet to do. I want you guys to practice using your trig formulas, either the triangle or the actual algebra rearranging, and solve from some side lengths. The answer key to these will be on the end of the PDF that I post with the worksheet. But in addition to solving for sides, I'm also going to have you solve for angles. It's a very similar process. So if we just take a look at number 1 here. Again, you're going to identify the angle that you're looking from. So here's my angle. Again, label your side. So hypotenuse, bottom is adjacent, all the way across is opposite. Erase the one that has nothing on it. So in this case, I'm erasing the adjacent. And O and H is sine. So if I go back to my formula triangles here, sine is opposite adjacent. In this case, I'm actually, I have both sides. I'm solving for this angle, this theta. So I'm going to set up this whole formula. My variables here, opposite and adjacent will be divided. And then we'll try to figure out how exactly we're going to do that on our calculators. So in this case, sine theta, sine of S, we don't know angle S, will equal opposite over hypotenuse, so 4/10. I'm just going to do this here. So sine of theta, or S, if you want to use the variable, equals opposite over hypotenuse, 4/10. You know that 4/10 is 2/5. You can turn that into a decimal, but I want you to do this all in one step. I want to know theta. So I need to get rid of this sine part of my function. I need to undo this part of my formula. To do the inverse on your calculator, you're actually going to hit sine -1 on your calculator. So most of the time you have to hit shift sign or second function sign to get the -1 with sine. And when you do this, it will turn 4/10 into an angle measurement. So sine -1 of 4 divided by 10 is a 23.578 degree angle. I'll just round this to 24 degrees. But the only extra step with angles is you have to do sine -1 or cosine -1 or tangent -1, depending on the information given. Let's take a look back here for a second. Yeah, let's do number 2. This is not a sign question. So we'll do number 2 for a bit of variety. This is my angle. Hypotenuse across from the 90. Adjacent is attached. Opposite all the way across. I'm erasing the opposite because I do not need that. I don't have any variable or numbers associated with that side length. A and H, that is going to be cosine. So look at my formula triangles. A and H is cosine. Again, I'm looking for theta, so I'm going to do A divided by H in order to get my angle measurement. So focusing on my triangle, cosine theta, or cosine C, will equal 6/12. Cosine theta equals adjacent over hypotenuse, 6/12. Again, I'm solving for theta, so I need to move this cosine over there. So now I'm going to end up having theta equals cosine -1 of 6/12. 6/12 is a half. You can change that to 0.5 if you want, but don't worry about that. Your calculator handles all of this. So to get that -1 with cosine, shift -1 or a second function, but do shift or second function cosine to get the -1 of 6 divided by 12, and we get that to be a 60-degree angle. So I want you to go ahead and solve the sides and the angle measurements. This may take you a little while. There's quite a few triangles here on both. Please check your answers. Make sure your calculators are in degree mode. Focus on the sides of the triangle given to you or you're solving for, and go ahead and practice these, and we will touch base soon.